Alright guys, so I hope you enjoyed this simulation here with Fed. Okay, so I just want to make sure that I touch on, just hit on each part before moving on forward with notes, okay? Here's part 2, adding a solid, okay? So what I'm going to do here is choose one of the solids, solutes, and why don't we just go with, I don't know, something blue, yeah, because I like blue, alright? And that is copper to sulfate, alright? I'm going to go ahead and label that as salt here, okay? Although I know that is not salt, but I like to think of solids as salts that I'm adding to a certain volume of solvent, which in this case is water, okay? Now, adding solid, here we go. So if I give it a shake, okay, over water, it tells me that now the concentration has increased from 0 of solids to 0.12 moles per liter of solid, okay? So if I continue to shake, yes, the solution has gotten darker, which means it is more concentrated, right? So that's the point here for part 2. Adding solid is that once you have a fixed amount of volume of water here, and if you continue to add salt to it, and what's going to happen is that the concentration will obviously go up and up. Okay, we say that the solution is very concentrated. Okay, all right, so that is part 2, and moving on to part 3 now. Okay, which is removing some of the solution. All right, so what does that mean? It means that, okay, I'm going to zoom out, make it whole screen. Okay, that's better. Okay, you can see that the concentration right now is 1.38. However, if I drain some of the volume of this solution out, what has changed? Okay, the concentration did not change. It is constant, right? However, I did lose a lot of the volume of water. Right, guys?
Yeah.
We good? Okay, so that's the point of part 3, is that once you have a certain concentration of a solution, no matter how much you try to get rid of the solution itself, the concentration will remain constant, right? And on the bottom side, there's like a little knob here that I can, from none to lots of evaporation, okay? Now, if you don't put a lid over this beaker, okay, what do you think is gonna happen in a few hours or so? They're going to start evaporating, okay? Now, how much of volume do we have here, guys? That's about 0.35-ish liters, which is a lot, which is like equivalent to, right here. My water bottle here, actually, it's about 500 milliliters, right? And I drank about, I don't know, 2/3 way, which this is actually pretty good amount, I'd say, of how much we have water here, okay? If I were to pour this into a beaker, would you say that it would completely evaporate in a couple of hours? Probably not, right? But if I were to put it over, I don't know, like a long flat plate, maybe a day or two, it would take some time, right? So the point of me showing you this right now is that evaporation, again, is the same way as pulling the knob and getting rid of the solution, okay? Again, the concentration will remain the same. However, the volume of water, I shouldn't just say water, the volume of solution will decrease. You got that? We good? All right, let's move on to the next part. What do we have here? Part number 4, which is adding water. Okay, good. Okay. So the thing about adding water, before I show and explain what I mean by adding water, I'm going to go ahead and zoom in here. Notice I have some solids on the bottom of the beaker. Okay. Why are they not dissolved? Does anyone know? Okay. Kind of talked about it before, right? I used the whole like elevator analogy, haven't I? Have I not?
No, you
So
have not.
I'm not. Okay, thank you, JT. So if you walk in, go on an elevator, right? And on one of the walls, it'll say capacity of, let's say, 8 people. Okay, and I'm gonna give it 1,000 kg. Okay, sure, that's fine. So that's the capacity, how much of mass that the elevator is able to hold. Does that make sense? So why am I using this analogy right now? Because it applies to solutions as well. Okay, how much water do I have here, guys? About 0.4, right, liters of water. Now the reason why the solid on the bottom is not dissolved, it is because it has exceeded the capacity. All right, going back to my elevator. All right, so 8 people capacity. So I got me, I got Gabe here, Ryan, Harris, Drew. Who else want to come on this elevator party? JT, Jude, Mike. That's 8. Okay. Now that is like the perfect amount. We're good. The elevator is able to accommodate 8 of us, right?
Yeah.
But Thano's like, yo, I want to join the party too, man. And he walks in, and the elevator go. What does that mean? We have now. Well, I'm not fat shaming anybody here. Sorry. I just mean we have exceeded the number of people, right? Okay. So Thano, I'm so sorry, but you, because of you, buddy, we have exceeded the capacity. Likewise, to our solutions example here, okay? It as in the water here, has exceeded the amount that it can dissolve. Does that make sense? So from here and onwards, I can continue to add more salt. Is that going to dissolve or is it not going to dissolve? It's not going to dissolve. Okay? All right, let's continue. So, part 4 is adding more water, right? So let's go ahead and add some water to it. By the way, notice that it says saturated. We're going to get back to that in notes later today, okay? So keep that in mind. Concentration 1.38. I'm going to add some water to it. Let's see. We're about 0.5 liters now, okay? 0.30, oh, that hasn't changed much. And I'm going to add a lot of water to it. Okay. Take a look. We're down to 0.9 for concentration, all right? Kind of like when you're cooking again, right? Making some beef stew or something stew, and you give it a try and you go, oh, that's real salty. What do you do to it? You add more water to dilute it. Does that make sense?
Yes.
Okay. Alrighty, so with that in mind, why don't we take this and the elevator analogy to our notes. So please go ahead and download your notes and begin taking some notes. Unit 7, Solutions, Note Sheet. Okay? Alright, starting with part 1. A few terminologies that are going to keep coming up throughout the unit that you need to understand, okay? Parts of a solution. There's 2 parts. The salt part, the water part, right? But let's give it its actual terminology, alright? So the solute is the substance that is dissolved here, okay? So I'm gonna give an example and I'm gonna call this the salt here, alright? I know they're not always salt. However, it just makes sense because we know that salt dissolved in water, okay? Solid. I'm gonna write down solid here next to it. Okay, they're not always solid, but for the most part in solutions, they're probably most likely going to be solids. Okay? Alright, so if we have salt, what else do we need to make a solution, guys?
Water.
Water, boom, thank you. And that is the solvent. Okay? The thing that is doing the dissolving here. Alright? We call this the water. Okay? Now, water, I want you guys to know, is considered the universal solvent. And the reason why it is that is because it can dissolve the most number of things in life. Okay, why don't we go and share a couple of examples of what things, what solids can dissolve underwater. Okay, so if I throw, let's say, Gabe into water, is he going to dissolve?
Nah.
Probably not, right?
Maybe
Okay.
after a while.
after a while, but probably not, right? So what are some things you know in life, okay, that you know that it can dissolve in water?
Salt.
Salt is one. What else?
Sugar.
Sugar. Anything else? Cocoa powder.
Yeah, it's like a bunch of powders.
Bunch of powders, exactly. There's a lot, right? As you know, again, water dissolves a lot of things, okay? So once you have salt and water together, you now have a solution, okay? I'm gonna call that salt water. Okay? All right, so that's the parts of a solution. Let's move on to concentration, okay? Very similar to the example that I shared with human population as well, how densely populated human population is, right? In the state of Illinois, we know that Chicago area is very concentrated with human population, right? Same thing. Concentrated, if you take it to the world of chemistry, it means that it's a solution that has a very large amount of dissolved solute. Okay, so go ahead and write that down. Solution So if a solution is very concentrated and you go, you know what, I kind of want to make this not as concentrated, what do I have to do to it? What's the reverse process?
Add water.
Add water, exactly, which means to dilute the concentration down, right? Water it down, as we say. Okay. That has a small this time. Okay, and there's a couple of diagrams to the right side to help us understand what concentrated is versus diluted solution. Okay, you can see that if something is very concentrated, there's a good amount of ratio between the salt and water, right? However, if something is very diluted, which means there's going to be a higher concentration of water versus very low concentration of salt. Okay, take a look. There's a lot more purple, which is water in this case, than the blue here. So that's diluted. Okay? All right, so let's go back down here, saturation. Now this is the elevator analogy that I explained to us, right? So I'm gonna write down the elevator analogy. Okay, so we're having an elevator party, right? And the capacity here is 8 people, all right? Now, what if there's only like 4 people on the elevator? Okay, we have not yet reached the capacity for the elevator party, and we call that an unsaturated solution, which means point at which a solution of a substance can dissolve more solute, which means we can bring in more people on the elevator. Anyone want to join us?
Of course so.
No? All right, so let's move on now. Okay, what about saturated, guys? Saturated means we have now reached the maximum. 8 people, right? So a solution which holds the maximum amount of solute possible at a given temperature, okay? Now I need you guys to understand here that at a given temperature, I'm just gonna go ahead and highlight in pink. I'm gonna go back to it in a bit, what I mean by that, okay? Let me know when you guys are good. Good to go? Alright, so here we go. Here's what I mean by a given temperature. Okay? Going back to my water bottle example here. So this is about like, I'd say 300 milliliters of water. Okay? So in my water bottle, it's not true, I'm just coming up with a random number right now. Let's say, I'm gonna take sugar. Not sugar, sorry, salt. Let's say I can dissolve 20 grams of sugar. By the way, how much is 1 gram again? Do you guys know? What was that? 1 gram is about 1 paper clip. Does that make sense? So if I say 20 grams of salt, that's about 20 paper clips amount of salt that I can dissolve in here, okay? Let's just call that the maximum saturated state, okay? However, you can actually increase the capacity by doing what? If I bring up the temperature of this water bottle, right now it's sitting at room temperature, which is around, I'm gonna go Celsius here guys, okay? So don't panic, all right? About 20 to 25 degrees Celsius. 25 Celsius, what does that mean? It means, again, room temperature, okay? But if I were to bring up the temperature to about, I don't know, let's say about 37, okay? Human body temperature is about 37, okay? What I've done now is that I've sort of expanded, I have increased the capacity that you can dissolve in this amount of water. So temperature can do that, guys. So if I crank up the temperature of this water, then I can actually dissolve more than 20 grams, maybe 25 grams of salt, maybe even 30 grams of salt. Does that make sense? Okay. Now, but here's the thing. Let's say, right now it's at 25 again, okay? I'm gonna bring it up to 40, ready? And I'm gonna dissolve 30 grams, which is 10 grams more than I can dissolve right now. Okay, and let's say it's hot and I bring it down to 25 degrees, which is, again, room temperature again. So what is that state then? That is considered supersaturated, okay? Supersaturated is when you exceed the amount of salt dissolved into the solvent. That is the super saturated state of a solution, okay? Has anyone built those like candy crystals before? Back in like elementary school or middle school? You've done the candy crystallization lab before? It's pretty cool, right? That's the whole point, okay? It's very unstable, and when you put in like a popsicle stick or maybe like a piece of string or something, the solids will latch onto it and begin to crystallize because there's too much salt that's dissolved into the solution, okay? All right, so that's called the supersaturated state of a solution. When you exceed the amount at a given temperature. So let's go and write that down. Might need that. Okay, more solute is dissolved than possible at a given temperature. Again, I'm going to highlight given temperature again. Just going to make a side note here, guys, okay? Every temperature has its own capacity. Is that cool? Just the way how there's different types of elevators, right? So if you've been to like, I don't know, Europe or even Hong Kong, like very, very small elevators that you can only fit like 2 people. It's crazy, I know, okay? Versus if you go out to like downtown Chicago, like John Hancock or something, you can fit like 20 people in it, right? So every elevator has its own capacity. Same thing, every temperature has its own capacity of how much solute that it can hold. Okay? So supersaturated, again, it's usually unstable and it will crystallize. Okay? Alright, so those are the different types of solutions as well. Now let's move on to solubility. Okay? Now I really enjoy talking a little bit about solubility here is because I always bring up actually I'm not going to use that example, sorry, I'm going to skip that. Alright, so when you say something is soluble, it means that the solute, is able to dissolve in the solvent. Okay. You know, I'm going to share that example. I mean, it's kind of relevant, maybe not relevant. Why not? I'm just going to share it anyway. So, I brush my teeth a lot. Like, I do it like 3-4 times a day. Okay, I carry around my toothbrush. I kid you not, right here. Boom. Anyone a Colgate person in here? Yeah.
I'm a Colgate person.
That's right. That's where it's at, right? No, I'm sorry, that's not Colgate. Crest. I don't even know my own brand. Colgate, I actually do have Colgate at home. But the reason why I'm saying this right now is I had my fillings done last weekend. 4 of them. My goodness, okay? But
Horrible.
thank God they're not all cavities. They're just chips. Because I grind my teeth a lot when I go to bed. And then there's a lot of chips, that's why a lot of fillings. But why am I sharing all this right now? Does it have to do with solubility? Yeah, it does actually. Alright? And the very top of your teeth enamel is made of this chemical that's called hydroxyapatite. Apatite, right? And the thing about that apatite is it's very soft and fragile. Okay? And when you have food stuck in between your teeth, over time, your saliva, which is a very strong enzyme, it will begin to decay away the food. But what's next to the food, guys?
Your teeth.
Your teeth. And it will dissolve away your teeth, guys. That's so scary, right? But why is brushing your teeth very important here? Because your toothpaste has a lot of fluorine, right, guys? And fluorine, actually, every time you brush your teeth, it puts a nice coat of fluorine on the very top layer of your teeth. It makes it really strong, and it prevents from being dissolved. So brush your teeth a lot. I don't know how relevant that was, but it talks about solubility, doesn't it? It talks about how it can dissolve, how to protect from being dissolved. So brush your teeth a lot, guys. Don't have food stuck between your teeth.
And what's up?
Gross. Floss your teeth. Okay. So let's move on. So that's soluble, right? How much it can dissolve. All right. Insoluble. Solute is unable to dissolve in the solvent. Okay? All right. Now, what about precipitate? No, it is not precipitation when water falls from the sky. In chemistry, the word is used a little bit differently, okay? Now, precipitate just means solids, okay? A solid that is formed from an insoluble solute. So we will use the word precipitate kind of like when I add a solution A to solution B, it will form precipitate, or it will precipitate, okay? Again, that just means it's producing solids. So, I'm gonna write down producing solids, okay? All right, and kind of like the picture on the right side here, guys, right? If I add solutions, it will begin to precipitate on the bottom, right? Solid, it has, I don't know, higher mass, so it will fall to the bottom of the test tube because of gravity, right? What about the liquid solution that's remaining on top? That is the other part that will not precipitate. that's all the vocab, okay? That's a lot of vocab, right guys?
Yeah.
Yeah, for sure. Okay, now let's move on to some actual like chemistry calculations. Yeah, there's more calculations in this unit, guys. But I'm not gonna lie, they're a lot easier versus the past units. Okay? Alright, so can I move on to molarity? Okay, here's a new unit. Okay, molarity is a unit that defines how much of salt is dissolved in a given amount of water or solution. Okay? So the number of moles, okay, per 1 liter of solution. Okay? Again, 1 liter, guys, is 1,000 milliliters, okay? The water bottle that I have right in front, guys, that is 500 milliliters, okay? So to make that 1 liter, I need 2 bottles, right guys? So that will be the molarity. Now, when do we use molarity? To describe concentration of a solution. Okay, when do I use it? I'm gonna write this down. My pen just died. Oh my goodness. I'm just gonna type here, guys. Sorry. To describe the concentration of solution. Okay, that's when we use molarity, okay? So let's go ahead and do some calculations now, okay? Just 3 and we're done for today, okay? So, just gonna do it on the board. Number 1, what is the molarity of a solution in which 0.56 moles of O2 are dissolved in 4.7 liters of solution, okay? Now, first, we need to understand what equation that we have to use here, right? Okay, the equation that we're gonna use here is molarity, which is big M, is equal to number of moles, which is small n, over volume. Okay? Alright, now I need you guys to understand that this is moles here, right? And volume is always going to be measured in liters, okay? So when you have something that is measured in milliliters, you're gonna have to convert milliliters to liters. Does that make sense? Okay? So why don't we go ahead and give this one a try, okay? So what do we have here? We are given 0.56 moles of oxygen. So what I'm gonna do is 0.560 moles divided by, what is the given amount of solvent here, guys?
4.7 liters.
Boom. 4.7 liters. Somebody do the math for me. Anyone?
0.12.
What's the unit? Big M, okay?
Yeah.
Big M for molarity, okay? So we can now say that this solution has what? 0.12 moles of this salt, I'm gonna call it, that is dissolved in every liter of water. That's how we describe the concentration here, guys, okay? So why don't you go ahead and give the second one a try here by yourself. I trying to find a molarity again for this question? No, very good. Okay. Please make sure you label all your variables first. Know what you are given and what you are trying to find. Okay. So what am I given here for this question? Well,
moles.
first, the number of moles. So N is equal to, what is that? Right here. 0.874 moles, okay? What else am I given? What else is given for this question, right?
The molarity.
The molarity. What's molarity that's given to us?
1.2 m.
1.2 m. Very good, okay? So now, I'm gonna go ahead and write down my equation for this. All my markers are not good. Sorry. Hope this one works. Oh, there you go. Molarity is equal to N over V, okay? Now, what am I trying to find here, guys? I'm trying to find volume, okay? So let's go ahead and now solve for V. We're gonna have to move around the variables a little bit. A little bit of algebra 1 here for you guys, okay? So if you move around, and you should be getting V is equal to N over big N. Do you guys all agree with me?
Yeah.
Yeah? So let's go ahead and plug everything in, right? Which is 0.874 divided by 1.2 molarity, which then gives me, what's my volume here, guys?
Zero 0.723, 0.728.
0.73 liters, okay? Because it's in volume, right? So I'm gonna go ahead and just kind of box around that as well. Done. That's my solution. Again, units are very important, guys. No naked numbers. Okay. Give it its units. All right, now let's go ahead and try number 3. Now, 3 is going to be a little bit tricky, okay? Because it's not just going to be a simple one-step process, all right? Take a look, because this one is in terms of grams, okay? If you, going back to our equation here, this big one here, okay? Do you see grams anywhere in this equation? No, but I see moles instead. So what you're going to have to do is to convert grams to moles. Try this one. Last one of the day, I promise.
Need a molar mass, right?
Exactly, very good. You have to use the molar mass of this. All right, all good? All right, so here we go. To convert from grams to moles, I'm going to be needing the molar mass of NaCl, sodium chloride, okay? So to find that, I'm just going to label NaCl. So we're going to refer to our periodic tables here, right, guys? Na is 23 plus, what is chlorine, guys? 35.45, right? So that's 35.45, which then tells me, okay, the molar mass of salt, table salt, sodium chloride, is 58.45 grams per 1 mole of the compound here, right? So using that information, why don't we go ahead and convert grams to moles, all right? So that's 4.5 grams of NaCl. Okay? So let's go ahead and flip that upside down because why? I have grams here, which means I want grams down here, right? So that is 58.45 grams is then 1 mole of it. Okay? Let's go ahead and make sure we convert it right. So here's what I'm going to do. 4.5 divided by the molar mass, which is 58.45. And I get, okay, here we go. 0.077 moles of NaCl. Okay, now I have everything in terms of moles. What do I need to do to find the molarity? Yeah, JT, what's up?
You gotta put 215 milliliters of liters.
Yep, 250, is that 15? So how do I convert 215 milliliters to liters now? JT, what's up?
Divide by 1,000.
Boom. Okay, and what do you get?
0.215.
0.215. Dividing by 1,000, there's 3 zeros in 1,000, which means you can just simply move the decimal to the left 3 times, right guys? Right. Okay, so I'm gonna go ahead and circle a couple of things. I know it's getting really messy here, right? So that is my number of moles, okay? And I know my volume, which is 0.215 liters, guys, okay? Not milliliters, okay? What do I do now? That's it. Take moles, put it right here. Take moles and divide it by 0.215. And that is, I got 0.36 for molarity. Raise your hand if you agree with me. Good. Wow, I'm like out of space. You know what? That can go away. I'm just gonna write down 0.36 molarity. Dunsies. Any questions? Could you pause the video, please?